I have some data here that I want to analyze with what we've learned about statistics so far. So this is from a study called Mindset Matters, and I have a description of that linked in the data if you want to read more about it. But a Harvard psychologist recruited 75 female maids working in different hotels. 41 of the maids, she told them that the work they do satisfies the Surgeon General's recommendation for a healthy, active lifestyle, which is true, and gave them examples about how this is so. The other ones were not informed of this. And then they measured various attributes of the women the beginning of the study and then 4 weeks later. And so what in general we know about these women from the data frame, the data set, is whether they were uninformed 0 or informed, their age, their weight at the beginning, their weight at the end, body mass index at the beginning, body mass index at the end, and so on. For this analysis, I just want to take a look at the body mass index after those 4 weeks. So we're just going to look at this variable here. And if you're not sure what BMI, body mass index is, it's your mass in kilograms divided by the square of your height in meters. And there are websites you can go to calculate your BMI based on feet and inches and pounds if you want also. So these are the BMI values for the women. The 0 in front means they didn't know that their work constitutes an active, healthy lifestyle according to Surgeon General, and the other ones do. And I'm going to ignore the 0s and 1s at first and just analyze the BMI. So I want to come up with some sample statistics first, and then we'll make some graphs. So sample statistics. And sample statistics, the standard ones we want to know are the count. How many numbers do we have? We want to know the mean. What's the average? We want to know the standard deviation for the sample. Let's see, what else do we want to know? I'm going to skip a line there. We want to know the minimum, the first quartile, the median, the second quartile, and the max. And we also want to know the range. And I'm just separating this out a little bit because the min Q1, median Q3, oops, and the max, they're part of what we call the 5-number summary. We use this to make a box plot. Standard deviation is a measure of the average distance each of these numbers is from the average, and mean is one way, or the middle. Mean is one way to get that middle. So again, standard deviation is always based on the mean. Those two go together. And it's always good to know the count again. So for this data set, I want to equals count. And the only thing that should be in this column is that data. So I should be able to safely select the column. And it should count that there are 73 numerical values in that list there. Mean is average. Again, since the only thing in the column is the title and the numbers, I can select the whole column. If you're ever in doubt about what it's safe to do, just grab the numbers in the column, and Control-Shift down arrow will eventually get you to the bottom of the list. And I should find that I get the same value, which just means it was safe to use the whole column. Standard deviation, there are many standard deviation formulas. We want the .s because this is a sample. So stdev.s is the one we want. We want to calculate that based on the whole data set. So what these two numbers tell me, and let's see, the BMI is to 1 decimal place, so we should round to 2 decimal places. In statistics, we usually go one more. Oops, I was hitting the wrong button there. One more decimal place than the data is presented with. So this tells me that the average body mass index of the people in the study was 26.2, and the average spread, the average distance away from the mean, is about 4. So again, the center is 26, and on average, people are about 4 away from center. All right, minimum. We could sort them and look, but it's safer to use the min command, the min function. Quartile, for those Excel users, quartile inclusive is the one to use. Don't ever use quartile exclusive. And we want to know which quartile we want. We want quartile number 1. So it's data, comma, 1 for quartile 1. And similarly, quartile 3, quartile inclusive data, comma, 3 for quartile number 3. So again, that marks the position in the list if they were in order, where about 75% of the other numbers are below this number. And the 23.3, that means about 25% of the values are less than or equal to 23.3. Median marks the 50th percentile, the second quartile. We're just going to use the median command. Again, the median marks the position in the list where about 50% of the numbers are below that point and about 50% are above. And just a reminder, that is also quartile 2. So if I did quartile inclusive data, comma 2, 2/4 is 50%, which is the median. Max. It's equals max. And then we can use these numbers to draw the box plot. So these 5 numbers right here, what we call the 5-number summary. Range is another measure of variation, and that is just the maximum value minus the minimum value. All right. And these just happened to come out to 1 decimal place. That's fine. Sometimes Q1 and Q3 can get a little funkier depending on the number of items in the list. All right, so those are all our summary statistics. Next, we want to make a histogram. And the easiest way to make a histogram in a spreadsheet like Google Sheets is to just say, hey, make me a chart. And sometimes it'll guess correctly and make a histogram, but sometimes it won't, and it'll try to do a scatter plot. Note, on a single variable, a scatter plot is less than meaningless. It's crap, it's garbage. Each value here is the height of the point. What's the x value then? Well, the x value is a 1, and then a 2, and then a 3, and then a 4, and a 5, and a 6, the order they're in here, which is kind of random. So this is nonsense. Also, nonsense would be just a straight bar chart on raw data. Nonsense. Histogram, not nonsense. All right, what's a histogram do? Histogram groups. It says how many of these people had a BMI between 15 and 18.13. How many had a BMI between 18.13 and 21.5? In the quick histogram builder, the lower number is in the column. So this column, somebody could have a BMI of 21.25, but if they have a BMI of 24.38, they'd be in the next column. So the lower bound is in, the upper bound is not for any particular column. Those aren't very nice numbers. Google guessed at 1, 2, 3, 4, 5, 6, 7, 8 columns here, and a width of about 3.13-ish. So generally, we don't want to accept the random value that they put in there. It's not completely random. Computer program calculated it. It was a good first try. So we could change that and pick a nicer number. Like starting at 15, I could jump by 5 for my bucket size. 1, 2, 3, 4, 5 columns. That's about the minimum you should have. That's not bad. 2 for the width. That's on the edge of too many, but not too bad. Is there a perfect histogram? No, there's many histograms. You just need to pick one. 3 is not too bad either. 4, and again, it doesn't have to be a whole number. It could be a fraction, like maybe you decide separating the BMIs by distance of 2.5 is the best way to go. All right, so it's your call. Pick something and go with it. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. The last one ended up being empty because the max is 37.2. Other things we can control. What was our min here? Our min was 16.8. We can control where to start and where to end. So I have control over the width of a bucket, and I have control over where to start and end. So I could instead start at 10 and go up to something like, I don't know, 38. And it will just redraw to accommodate that. I think 15 was a pretty good start. The smallest number was what, 16.8. So 16 wouldn't be a bad starting number either. And notice it looks slightly different. So different things happen each time you change some values. All right, so again, what's the best histogram? There's just lots of choices. Do I really like 2.5? Nah, I'm gonna go to 3 again. All right, I like that histogram right there. Those are pretty numbers. Next thing we should do is put in relevant titles. Titles here. So BMI 2, it's not the greatest title for that horizontal axis. So I'm going to call it BMI. Hopefully people will know what that means. If they don't, I should spell out body mass index. And I'm just going to say 4 weeks later. So what that measurement is. What's this vertical column? Well, that's my frequencies. Frequency is how many were in each group here. And frequency of what? Frequency is a count. What am I counting? I am counting people. So I'm going to call that number of people. And then histogram of BMI is kind of a lame title for the whole thing. Let's pick a better title. All right. Naming things is hard. It's not always easy. What am I going to call this? Body mass index of hotel workers. They have a subtitle here if I want to add more. Let's add a subtitle to go with that too. 4 weeks into the study. And do I need BMI 4 weeks later? If I say it up above, nah, we can just call that BMI. Cool. So I have reasonable titles. Nice. Editor can go away, and we can just slide that over here. So next thing I want is a box and whisker plot, and there's several ways to get that in here. I could just draw it based on those numbers there. So I'm going to give that a try. So I have to use, I'm just going to make a note here on paper, 16.8, 23.3, 25.6, 28.5, and 37.2. And I think the nicest way to display a box plot is with the histogram. So we can just use the scale that Google has created for us on the bottom here, except 34 to 37, 37 to 38 is a problem. So they should all jump the same. So I better make that maximum there a 40 so that my scale is correct. So I'm going to edit and fix, customize, horizontal. So me forcing it to end at 38 was a bad idea. If I get rid of that, I might just pick a better end value. Yeah, it picks 40 so that each column is the same width, which is what you want for a histogram. So usually it's a good idea when you make a histogram in Google, that is, with the quick histogram builder, is to pick the start value and the bin width, the bucket width. And again, there's no perfect choices on those, there's just choices. So what I'm going to do is I'm going to click on this and I'm going to copy it, Control C, and then I'm going to jump in and I'm going to insert myself a drawing where I'm just going to draw on top of it. So I'm just going to paste that in, unlinked. Linked means if you change anything here, it'll change there too, but I'm pretty good with what I have now. And I just want to draw a line. Click off of it first. Come on, there we go, there's a line. All right, let's try that again. Delete, draw a line, and I'm gonna put it right here at the bottom. And will it let me go horizontal? There we go. Oops, I keep extra clicking. And then once I draw it, then I can control things like the color. Let's make it dark blue, and let's make it a little thicker. All right, so then I have to lay out my numbers. So let's see. For my box plot, 16.8 was the smallest, so that's 19. So I'm just gonna drag this, there we go, over to, where would 16.8 be? 16, 17, 18, I think it's gonna be around right here-ish, based on the scale above. So 17's there, 18's there, 16.8. Same thing on the other side, my max was 37.2. The max is gonna go just under 37 here, about there-ish. All right, and then I'm gonna draw some more lines for Q1, 23.3. So there's 22, 23, 24. So 23 is around here-ish. So draw a line there. And then 28.5. There's 28. 28.5 is going to be around here-ish. And then we do a box from Q1 to Q3. And then in the middle, we draw our median, 25.6. So that I think is going to be around here-ish. And often on the box and whisker plot, they put little tails out here on the edge. That's optional if you want to, but just ending in the right spot, I think, is sufficient. Oh, stop that extra line. Oh, I just moved it. All right, so drawing with a mouse can be a little tedious, but that's not too bad. All right, there we go. There's my box plot based on the numbers I calculated over there. If I save and close, it will throw that in here. So I'm going to move the original out of the way and slap my new one with the box plot right here and just shrink that down a little bit. Cool. So there's the box plot that has my min Q1, median Q3, max drawn in underneath. And what I should expect to see is anywhere there's a narrow quarter, like the second quarter here, that's where a tall stack is. The third quarter here between median and quartile 3 has another tall stack. And anywhere there's shorter stacks, I should expect to see a long quarter. And a reminder, what are these numbers telling me here? The first quartile marks a number for which 25% of the data is below that. So each of these 1, 2, 3, 4 sections is corralling 25% of my data. All right, so if you didn't want to draw that by hand, my recommendation, my favorite box plot builder is at Statkey. Statkey, so just search for Statkey and lock 5 Statkey is what we want. And we're doing one quantitative variable. And what we do is just go grab our data, starting with the title, and then go down to the last number, copy it using Control-C on my keyboard, and then I'm just going to edit out their data. So I'm just going to highlight all of their data, delete it, paste mine in, and then I'm just going to pay attention to a couple of things. Do I have a first column identifier? Right? Is there something to the left of each of these numbers saying whose number it is? Like the first one's Gary's and the second one is Joe's. No, there's not. Get rid of that. Data has a header row. And yes, I did have the header there at the top. So, okay, select it. And what I should find is I should get pretty much the same sample statistics on the side there. So let's just compare what Statkey says to what I calculated. There you go. Okay, so I had a count of 73 and Statkey has a count of 73. Let's blow Statkey up a little bit. I have a mean of 26.22, and so does Statkey. Standard deviation of 4.27, so does Statkey. They have the right min. Now, quartiles will differ. So it turns out there is no standard way across the world to calculate quartiles or percentiles. And so some software will give slightly different numbers. In this case, my quartiles happen to match in the spreadsheet and Statkey. But Statkey and the spreadsheet use 2 different techniques to find quartiles, so sometimes they won't match. But they'll be in the ballpark, no big whoop. All right, so why am I at Statkey? Because they have a box plot builder right there. And their box plot has an enhanced feature where they're making a cutoff on the right here, and they're saying this value out here is unusually large compared to the rest. It's what we call an outlier. And I didn't go over techniques for identifying outliers in this class yet, but maybe you read about them somewhere else, or you'll learn about them in another class. But there are techniques for identifying when some numbers seem to be unusually small compared to the rest of the data, or maybe unusually large compared to the rest of the data. If I want to use the Statkey graph instead of drawing my own, then my only choice is to do a screenshot. So get your snipping tool or screenshot tool on your computer. I'm going to use this one here and grab a screenshot of it. And since I'm using a Google Sheet, I can just copy and paste it in there. If you're putting this in something like Canvas, you would have to save it and give it a good name. So keep that in mind. I'm putting it in my spreadsheet so I can copy and paste it. So let's say I'm going to stick this with the other chart here. And then what I want to do is once I paste it in, I want to resize it so it lines up with these numbers above. So to do that, I'm just going to start by scaling it down, and then I'm just going to drag it above so I can see those two together. And I just want to get these numbers kind of lined up. So 17.5 is probably right there-ish. And then 35 would be over here-ish. 37.5, so it's kind of a pain. Almost. Pretty close, maybe a tiny bit bigger. Yeah, so now I've got them adjusted so these scales, different numbers, but they're in the ballpark of working together. And so now I'll just squish this to sit underneath. So now I have a comparable box plot scale that matches my histogram scale. So I thought drawing it by hand was pretty good. Other cool things about Statkey is it'll also make histograms. Where'd Statkey go? Over here. Oops. Statkey, where'd you go? There you are. Stick you back here. So I have a histogram builder, and it works a little bit different than the Google one. Once you edit your data in there, you can set the limits by controlling the minimum value, the maximum value, and how many buckets. So Google lets you do the bucket size, Statkey lets you do how many buckets. So if I started at 16 and went up to 40 and made 10 buckets, I think that's pretty much what I did in Google. This should be pretty similar to what I ended up with in Google. So it's just a different way of coming up with it. And Excel does it kind of like this too. If you want to do this in Excel, you can't control the box plot. The box plot is what it is based on the min, Q1, median, Q3, and the maximum. So the last thing you want to do for a situation like this is then look at the statistics and look at the graphs and what do they tell us about this particular set of body mass index numbers. Well, I can look at this and say most of the people in the study, you know, if I pick the biggest 4 columns, they had a BMI between 19 and 31. Okay, could I be more specific about most? Yeah, I could tell you how many are in each column and say like, you know, 80% of the people had a BMI between 19 and 34. I could be more specific looking at Q1 and Q3, that's the middle 50%. So I could say, hey, the middle 50% of people in this study had a BMI between 23.3 and 28.5. Very few people had a BMI above 34 in this study, and only one person had a BMI below 19. The average BMI was 26.22, and the median was a little bit lower. Now, what does it mean that the median was lower than the mean? What it means is there was at least one person with a higher BMI than most people that is in the study, that's dragging the mean away from the median, right? Again, think about that. The median just says, hey, there's 73 numbers. The middle number is about 25. Now, the middle number doesn't care who's at the upper end or the lower end. It doesn't matter whether the highest number was 40 or 50 or 37.5. It was 37.2. So even if I went into this data and edited that 37.2, it's not going to change the median, but it will change the mean. So the mean is subject to extreme values on each end, being biased by them, where the median is not. So sometimes the median is a better measure of center if there's some people or some items that are skewing the results. And I would say this data is skewed to the right. There's kind of a tail out to the right there. So that would be something else I could mention about it. So again, what comments can you make based on the summary statistics and the charts that we have here to discuss the range of values and how they're clumped or not clumped for this particular group of people on their body mass index? That's the point of statistics. Nobody wants to look at a big long list of numbers. They want somebody to describe the numbers to them. And so that's our goal here. Next thing I want to do is just for fun, so this is a little bit of extra fun, I'm going to consider both the BMI and whether they knew their work was what represented an active, healthy lifestyle. And to do that, copy, I'm going to go back to Statkey, and they've got this really great tool called two quantitative variables. And I'm going to go edit the data. Is this the one I want? Wait a minute, this might not be the one I want. No, these aren't two quantitative data variables. I have a categorical variable and a quantitative, right? Categorical, did they know or not? And then quantitative is what was their BMI. That's what I want. All right, there we go. Edit the data. So we're just going to compare the two of them. So we have a label and a value. Label is did they know or not, 0 or 1. And then the BMI. Okay, so what Statkey is going to do is going to look at this data and it's going to group them, and it's going to make a histogram separately for each group and a box plot separately for each group. So this is going to be kind of fun. Okay, so what are the groups? The blue ones are, that must be the zeros. Let's see. The minimum for is 20. Oh no, I lied. The bottom one is the zeros and the top ones are the ones. So the bottom are the people who didn't know that their work was healthy, and the top one are the people that did know. Because the min for the zeros, wait a minute, did I get that backwards again? The zeros have a bigger min. Okay, one more time. The bottom one is the zeros, people who didn't know their work was active and healthy, and the top one is did know. And they're going to do a histogram comparing the two. So again, bottom one right here is people who didn't know their work was healthy, and the top one is people who did know. Boxplot. Didn't know 0, there's the 0 there, and the top one is did know. So the people who didn't know, they have a much larger range of a body mass index, and there's a narrower range up here. The middle 50% of people who knew their lifestyle was active and healthy, the middle 50% is smaller overall than the middle 50% of the people who didn't know. And the point of this study was, is it true that your thinking affects your health? Right? If you're told what you do is healthy, did it make a difference? Well, the BMI was smaller for the people who believed or were told their work was active and healthy. So maybe, kind of cool. All right, that's it for now. Take care, do good math.